Hello aspirants. Sorry, actually yesterday I stopped recording the lecture. I was just fatigued after office hours. Okay, no problem. So now we are energetic and let's start from there only. So where we were studying symmetric group in which I have defined functions. This is n factorial because number of 1 on 2 functions on a set with n symbols so how many 1 on 2 functions we can define on a set with cardinality n मतलब एक ऐसा set that has n number of elements. So how many 1 on 2 functions we can define over that? Those are n factorial. Okay, if you didn't study it in the permutation combination, I can teach, but this is n plus 2 level. Yes, one more thing I will say, if some aspirants struggle in these basic things, what I am going to do is, you can just tell me in the comment section ki sir this much, these basics part I also need. I will take some extra classes for those parts, because if we will be engaged on such basic every terminology, our syllabus will not be completed. I am ready to take extra class. You only just tell me in the comment section what extra things you need. Okay, so as I told you yesterday, a group of permutation is a collection of all 1 on 2 functions on a set with n elements or with n symbols. So when we talk about Sn, it is not independent. It has some hidden set that is with n symbols. And over these n symbols, I have defined n factorial number of 1 on 2 functions. So this is group of, अभी group तो बोले क्या? If it will follow all those axioms, we will call it as a group, or otherwise right? So to talk about group, what we need here, what I told you, we create an algebraic structure. That means a set and a composition or operation. So what I am going to do is, I am just trying to take this operation that represented by star. This I defined as composition of functions, because what Sn has functions as elements. And how it is going to be defined? We say f of z of x means, see, please be on the board, make it very clear. I am taking composition of two functions. Okay, and let's say I have defined like this, f of z of x means what, dear? If I want to check what is the image of the element, let's say a2, by the function f o g, so I will take this as o. It will be nothing but f of g of a2. Let's say g of a2 comes out as some AI, and f of AI, let's say it comes out AJ. Getting my point? That means FOZ of some arbitrary element gives some element of the set this AJ. This will also be image of some function or not, because you have defined one on two function, means any element of this set will not be like that which is not image of some function. If you pick any element from this codomain, definitely that is going to be image of some function. Why? Because this is one on two. Onto means there is no element left here which is not image of some sub element under that function. So let's say it is image of some function h of the element. What it says here, कि when I compose these two functions, I get another one on two function on the set S itself. So this implies that if I define composition of functions like this, then applying this composition between any two elements, we are going to get a third element which is nothing but only an element of this set itself. So what you called here, this composition is a binary operation on the set Hn, or you can say this structure is an algebraic structure. Is that clear to you all? Fine. Second property, what you need is associativity. So when we started studying about functions at the 10+2 level, we always studied that composition of functions is associative. Do you remember? If not, then you can go like this: FO, ZOF. Try to find image of this. We'll be having FOZ of HX. So composition of functions follows associativity. Try to remember this for further studying in this topic. We'll not be doing this stuff again and again. If somewhere we encounter with the composition of functions, we will say those follow associativity, and at that time you will recall these things. Is that clear? In the same manner, I can talk about identity. If I take a function I as, देखा, which mapped each element to itself only, then if you take composition of I with F or F with I, you are going to get F of X only. Don't worry, after this I will take some example S3. That example will make everything clear. But why I am doing this stuff here? Because many of you guys are avoiding this thing. But dear, in case of examination, if you are not writing such theoretical concepts, you are not going to get good marks. If you are talking about symmetric function, then you cannot take an example of S3 and will detail all those things in within an example. Example are okay. Those can make you stuff as understanding manner, but you need to know how composition of functions are defined, how we can write those composition functions. Is that clear? So identity हो गया. After this, you can talk about inverse axiom. Means for each element of this set, there exists some element in this set only, such that if you compose those, you get the identity function. Is that clear to you all? Then we say कि yes, this composition of functions on this set Sn, they follow inverse axiom. Is that right? Is it clear to you all? Fine. So this was the general explanation for Sn. Now I am going to take an example and let's see how these things work. Is that clear? Fine. So let's talk about S3. Now tell me, it will be comprises of functions. How many 1, 1 on 2 functions, dear? Factorial 3. That means 6 elements. If you want to get those 6 elements, in the previous lecture we have discussed that how those functions looks like. Okay, one more thing I will tell you guys. This S3 and S4, your UPSC PYQs will be directly or indirectly depending on this S3 and S4 for sure every year. Either you can get the questions regarding orders of the element, possible orders in S3, S4. You can have the question regarding the alternating group, which I will proceed further. You can have different questions from this S3 and S4. So let's start from the S3 only and we'll go move on. So dear, if I'm talking about S3, obviously I will have some set of symbols. Let's say these symbols are 1, 2, 3. Don't take it as numbers. Those are symbols for you. Okay. So how I have defined, please be on the board. I1, ठीक है? Let's say I have a function. From here onwards, I will be taking these notations as sigma 1, sigma 2, sigma 3, tau 1, tau 2, tau 3. And why I'm writing? Because I will not be writing this stuff each time. Obviously, this will become cumbersome. So when I will be writing such function where 1 is mapped to 2 and 2 is mapped to 1, 3 is mapped to 3. So I will denote this function as sigma 1. Okay. So 1, 2, 3. 1, 2, 3. Let's say 2 is mapped to 2, 3 is mapped to 2, 1 is mapped to 1. You're getting my point? I will call it as sigma 2 or represent it as. Similarly, I will represent sigma 3. 1, 2, 3. 1, 2, 3, where 1 is mapped to 3, 3 is mapped to 1, and 2 is mapped to 2. Is that clear? I will also define two more functions, tau1 as where 1 is mapped to 2, 2 is mapped to 3, and 3 is mapped to 1. I will also define a function tau2 as where 1 is mapped to 3, 3 is mapped to 2, and 2 is mapped to 1. And now onwards, I will be using this notation when I will say S3. You will understand that I am talking about I1, sigma 1, sigma 2, sigma 3, tau 1. Is that fine? So now onwards, if you are following this lecture continuously, whenever I will talk about sigma 1, what do you understand as this function? Don't worry, with passing time, it will be easy for you guys. When I move to the cyclic representation, it will be clear to you. Chalo. Now, composition of functions. Let's see how this composition of functions works on these elements. Just for example only. Let's take here only. For example, if I say what is sigma 1 composition sigma 2? Composition of two functions. So what is sigma 1, dear? Is a function. Sigma 2 is a function. That means I want to know what is the image of 1 under the function sigma 1 composition sigma 2. This I want to know. What is the image of second symbol? Similarly, what is the image of third symbol under this function sigma 1 composition sigma 2? So how it will be written, dear? Sigma 1 composition sigma 2 of 1. Is that clear to you all? This will be written as sigma 1 sigma 2 of 2. This is sigma 1 sigma 2 of 3. Any doubt here? Okay. Now tell me, sigma 1 sigma 2 of 1 is what? Sigma 2 of 1 goes to 1. Getting my point? And what is sigma 1 of 1? Where is 1 mapped? 1 is mapped to 2 and 2 is mapped to 1. So 1 is mapped to 2. So sigma 1 of 1 is 2. So ultimately, dear, this element will be 2. Is there any doubt? If doubt persists, I will compose this also. Let's say, what is sigma 2 of 2? 2 is mapped to 3. So this will be sigma 1, 3. And what is sigma 3? Sigma 1 under 3 is 3 only. So this element will be 3. Similarly, I can compose this sigma 2 of 3. Sigma 2 of 3. 3 goes to 2. So this will be sigma 1, 2, and sigma 1 of 2 is 1. So if I want to know what is sigma 1 composition sigma 2 is, See, सिग्मा 1 कंपोजिशन सिग्मा 2, 1 का इमेज 2 दे रहा है, 2 is mapped to 3 and 3 is mapped to 1. I will write here. Sigma 1 composition sigma 2, under this function, what is happening dear? Tell me. 1 is mapped to 2. 2 is mapped to 3 and 3 is mapped to 1. What happens? Check it out. This function where 1 is mapped to 2, 2 is to 3, 3 is to 1. This is nothing but tau 1 only. You got my point? That means when I compose sigma 1 and sigma 2, I got the result as tau 1, which is also an element of this S3 only. Getting? Chal. Now, abhi you people will think, sir, this much calculation or this much writing we need? No, not at all. Just to make you understand, I have derived these things. For calculation, just see. Please be on the board. I will write as sigma 1. What is sigma 1? Where 1 is mapped to 2, 2 is mapped to 2, 2 is 1, 3 is mapped to 3. What is sigma 2 dear? Where 1 is mapped to 1, 2 is mapped to 3 and 3 is mapped to 2. Now I want to compose sigma 1 composition sigma 2. Please be on the board. Is it visible? Yes, fine. What I want to know is, after composition, this is function only, na? So what is image of 1 under this function? What is image of 2 under this function? What is image of 3 under this function? Got it? So this is the, you can say, domain part, and I will write in the second row as the image part or range part. So sigma 1 composition sigma 2 will be what? That I want to know. Now start from here. Abhi I want 1 ka image here. So I will check. Please be on the board. I will tell only once and it will be much clear to you. 1 ka image 1 and here 1 ka image 2. So here 1 ka image 2. Once more. 2 ka image 3 and 3 ka image is 3. So this will be 3. 3 ka image is 2 and 2 ka image is 1. So it will be 1. What it is? Check it out. 1 ka image 2, 2 ka 3, 3 ka 1. This is nothing but tau 1 only. So what you got dear? Sigma 1 composition sigma 2 is tau 1. Is that clear? Similarly, you can talk about what is sigma 2 composition sigma 3, what is tau 1 composition tau 2, what is tau 2 composition sigma 3 and all. These all compositions you can find, and that is a task for you guys. Composition table for S3. How you will write? I sigma 1 sigma 2 sigma 3 tau 1 tau 2. Here I will write sigma 1 sigma 2 sigma 3 tau 1 tau 2. So how you compose? From left to right. If I compose I, identity function only, so this row you will be getting the same. Sigma 1 composition I will give you sigma 1 only. If you want to check, you can check. Sigma 1 was I was, check it out, 1 का इमेज 1, 1 का 2, 2 का इमेज 2, 2 का 1, 3 का 3. So this is what? Sigma 1 only. So sigma 1 composition I is sigma 1. What is sigma 1 composition sigma 1? Sigma 1 composition sigma 1. What you will write? 1 2 3 2 1 3. 1 2 3 2 1 3. What it will be, dear? 1 का इमेज 2, 2 का 1, 2 का 1, 1 का 2, 3 का 3, 3 का 3. What it is? Identity. So sigma 1 composition sigma 1 giving you the identity. Getting my point? So you can say sigma 1 is inverse of sigma 1. In the same fashion, you can calculate sigma 2. You will be getting I only. Sigma 3 composition sigma 3, you will be getting I only. In the same fashion, you can compose tau 1 composition tau 2. Let's see. 1 2 3. This is tau 1, this is tau 2. What it will be ultimately coming out? 1 का इमेज 3, 3 का 1, 2 का 1, 1 का 2, 3 का 2, 2 का 3. What it is? I only. So you can call tau 2 is inverse of tau 1 or tau 1 is inverse of tau 2. I have just given a hint for you guys. Now you can fill this table. This is homework for you. How you will fill? You will just compose these things. In the exam hall, no one is going to ask you to compose all these things. But here inside the class, why I am saying, dear? Because if you are good at compositions, then in the exam hall or during the preparation, you feel comfortable. Okay, composition of functions is not a big deal. Is that fine? So you can fill this composition table, and after filling this composition table, what you will get as I is an element such that when compose any element with I, you get that element itself. So I will work as an identity element. Inverse axiom for I composition I is I. Sigma 1 composition sigma 1 is iota. Identity element, you call it is volley, whatever you wish. Similarly, sigma 2 composition sigma 2 is I. Sigma 3 composition sigma 3 is I. Tau 1 composition tau 1 composition tau, you will be getting I only. Tau 2 composition tau 2, you will be getting I. Also tau 1 composition tau 2, you will be getting I. Everything I have done. So what is remaining? You can just fill the table. Why I am writing here? Actually, I have a purpose for this. Because if you have these things on your tip, things become easy. How to take example? If someone says, give me 3 elements which are self-inverse in S3. Sigma 1, sigma 2, sigma 3. Give me 3 elements which are composed 3 times. Then they give us identity. Tau 1 and tau 2. Is that clear to you all? Composition of functions is clear? Okay. Now one more point I would like to discuss here is see, if you compose tau 1 composition tau 2, check it out, and you compose tau 2 composition tau 1, or you can compose sigma 1 composition sigma 2 as well as sigma 2 composition sigma 1. Do such compositions and compare these two. What you are going to get, note it down. In this scenario, you will be getting key what? Shame. Then compose sigma 1 composition sigma 3 and sigma 3 composition sigma 1, or tau 1 composition sigma 2 and sigma 2 composition tau 1. Why I am taking combinations like this? I have an intention. You will not be getting same image for this A operation B and B operation A. And in that case, you say that S3 does not follow commutativity. Or you say this is a group but not abelian. Getting my point? This is very good example. S3 is the, you can say, first non-abelian group, or you can say a non-abelian group of minimum order. Don't worry about order and all. We will be discussing in the coming lectures it. But S3 is very famous example, and that is not example, this is very category actually. Because first non-abelian group this is, that is why it becomes famous, or you can say it becomes a popular category where you want to check like what other concepts, how they are working with S3, S4 and so on. Is that clear to you all? Should I move forward? Let's take some water. Now, what I will discuss is, you people will say ki sir ऐसे how I will remember all those stuff, what is sigma 1, what is sigma 2, what is sigma 3 and all. So there we have cyclic decomposition of permutations, or you can say those functions you have taken na, in the Sn. Means, let's say I have a permutation where 1, 2, 3, 1 is mapped to 2, 2 is mapped to 1, 3 is mapped to 3. I will represent it as 1, 2. What this cycle says, please listen. The next element is the image of its previous element. If I have a cycle A1, A2, A3, dot dot AN, and I call it as F, then F is actually, dear, a function from A1, A2, AN to A1, A2, AN, such that the next element is the image of the previous. So A1 ka image under the function F is A2, A2 ka image is A3, A3 ka image is A4 and so on, and AN ka image is A1. You getting? So either you write this function or represent this as this. Clear? So this is called cyclic decomposition of some function. When you write like this, if some element is not in cycle, then it is supposed, or it is said, that is self imaged or self mapped. Means, see, that doesn't mean you will have infinite number of, you will have a set of symbols first. So let's say you have set of symbols as with 3 symbols only. And in a cycle you have only 2 elements. Then you will say the third element is self-imaged. So what it is representing as 3 is mapped to 3 only. Is that clear? So this is sigma 1. And how you represented sigma 2? Tell me. 2, 3, 3, 2, 1 is mapped. So this I will represent it as 2, 3. This I will represent as 1, 3. So this is sigma 2. This is sigma 3. How it will be represented as 1 का image 2, 2 का 3, 3 का 1. This is nothing but tau 1. And this is represented as tau 2. So we will be taking S3 as I means each element is self-imaged. 1, 2, 2, 3, 1, 3, 1, 2, 3, 1, 3, 2. So this will be my S3. Here this is sigma 1, sigma 2, sigma 3, tau 1, tau 2. Is that clear to you guys? So in the cycle form, it will be written like this. So why I have told you the cyclic decomposition? Because this has huge importance in this topic. I will have a term here, transposition. In simple word, a cycle of length 2. When I say 1, 2, 3, please check it out. Will it give the same result as this? If yes, then this element can be represented by this also. So this is a cycle of length 2. This is a cycle of length 2. So that means this element has 2 transpositions. One is this transposition, another is this. A cycle of length 2 is called transposition. Is that clear? Why I have taught this definition? Because we have a categorization, even permutation and odd permutations. Number of transpositions are even. That means if you want to check there whether a given permutation means that function only, sigma 1, sigma 2, sigma 3, tau 1, tau 2, I and all, these are functions or someone called permutations only. So if someone says ki check whether sigma 2 is an even permutation or odd permutation, whether tau 2 is an even permutation or odd permutation. So what does it mean, dear? It means you have to first represent that given. Please note it down. If you want to write, you can write. If a permutation is represented into cycle form or cyclic decomposition and number of transpositions are even, then that permutation is called even permutation. If number of transpositions are what? Cycle of length 2. If number of cycles of length 2 are even, then even permutation. If odd, then odd permutation. यहाँ तक clear है शब्द को? So, if I talk about S3, so what it is? I sigma 1, sigma 2, sigma 3, tau 1, tau 2. What is sigma 1? 1, 2, 2, 3, 1, 3, 1, 2, 3, 1, 3, 2. Identity permutation will be always even. Is that clear? And that you can add with the zero transposition or whatever you wish. So identity will come out in the category of even permutation. चलो, so this is sigma 1 क्या है? Just a cycle of length 2. So sigma 1 contains, or sigma 1 represented as a cycle, only one cycle. So 1 is odd. So sigma 1 is an odd permutation. Sigma 2 is an odd permutation. Sigma 3 is an odd permutation. If I call 1, 2, 3, so first I will decompose it. So number of cycles of length 2 are 2. So this will be even permutation. Similarly, this will be even permutation. And in short, if you wish to have, I will say A1, A2, AN. Suppose that these are n symbols or n length cycle. If n is even, then its cyclic decomposition will containing odd number of transpositions. And if n is odd, then obviously this will compiled of even number of permutations. Sorry, even number of transpositions. So that means if length of this cycle is even, then that permutation will be odd, and if this length is odd, then that permutation will be even. Why? You can take help with these examples. Is that clear? Even and odd? Fine. Let's move on the next. Why I have taught you this even and odd permutation? So with S3, I can take out a set A3 as I, tau 1, tau 2, and I call it as set of even permutations. What? Set of even permutations. Now you can find the composition table for A3. So I composition I, tau 1. What is tau 1 composition? Tau 1. You can check it out. 1, 2, 3. And 1, 3, 2. What will happen? Here 1 ka image 3, here 3 ka 1, here 2 ka image 1, and here 1 ka 2. And this is 3. This is identity. So tau 1 composition, tau 2 will give you identity. In the same manner, you can compose tau 2, tau 1. This is same as tau 2, tau 1, because inverse है एक दूसरे के. I. So what this composition table says, each element is coming from A3 only. So this composition is a binary operation on A3 or closure. Composition of functions follows associativity. So associativity axiom followed. Identity, here I will work as identity element of A3. Inverse, I ka inverse I, tau 1 ka inverse tau 2, and tau 2 ka inverse tau 1. That means all those 4 axioms are satisfied. So A3 with respect to composition of functions is a group. and this is very famous group. In the whole algebra, we will be dealing with such group, and this is called alternating group. Okay, so is it abelian? Yes, it is abelian. tau 1 कंपोजिशन tau 2 कर लीजिए, tau 2 tau 1 कर लीजिए, and I के साथ तो हो गई. So ultimately this is an abelian group, whereas S3 was non-abelian group. Is that clear to you all? So now let's move on S4. So S4 will be what? Set of all, एक बार और लिख देता हूं फिर 1 on 2 functions on a set of symbols with 4 elements. That means the set will be comprises of 4 symbols S, and I will define all possible 1 on 2 functions from S to S only. And how many functions you will be getting is 4 factorial. That means 24. So you can write all those functions like, if I take I, just I give you a hint, you can try. I 1 image 1 2 ले लिया, 2 3 ले लिया, 1 3 ले लिया, 1 4 ले लिया, and like this you can write all those 24 elements of this S4. I will suggest before the exam hall write these elements, because UPSC CSE as well as IFOS, you will get previous year questions based on this, not directly on elements of S4. They asked questions about A4. So this is alternating group, and किसके लिए सबसेट है? S4 का. Similarly you can talk about S5 A5, S6 A6, Sn An. Okay, Sn An. So this is called alternating group. Okay, moreover A3 is abelian, but A4 onwards you will be getting as non-abelian. Please make it a point. UPSC focused on this A4 multiple times. Okay, so you have to write elements of A4. What I suggested, you need to have definitions on your hand. A4 is what? Set of even permutations coming from S4. So you have to write those even permutations. You know, this will be odd permutation and this will be odd. Just a hint for you. If you compose 1 2 2 3, what you are going to get? Odd composition, odd. Is it even? That is key point for you to construct or to write elements of A4. Why? Because you will just compose these 2 elements. You can write A4 like I will be always there, 1 2 composition 2 3. Similarly, you can write an element 1 3 2 4 composition and so on. You're getting my point? Similarly, 1 2 3, 1 3 2, 1 2 4 means इसका हिंट देखिएगा. Many people, many students are confused. Even I can write the whole set because last 14 years I have been writing this, but that doesn't make sense because again you will think, okay, ये तो होता है, I have to cram it. बस रट्टा मार जिंदाबाद है ना? No, not like that. Please remember this hint. What I said here, you need to have elements in A4 as even permutations, and even permutations are what? Transpositions. Number of transpositions are even, that means cycles of odd length. First category, cycles of odd length. Second category, composition of two cycles of even length. Getting? Is that clear to you all? So if you write like this, you can construct A4, and at the end of the day, I will suggest you guys to remember this A4. What I'm saying, first you write A4. If you are not able to write, do let me in the comment section that, sir, please tell me I am not able to construct all those elements of A4. And how many elements of A4? Sn will be comprises of C, n factorial total elements, n factorial by 2 even, and n factorial by 2 odd permutations. So here in the A4 you will have 12 elements. I'm not in the habit of again do the Rattamar for algebra. It is very much in understanding nature. Again, it depends on us how we take it. So construct A4. Fine. Please do remember these stuff what I told. This will be very much helpful in your UPSC exam. Should I move? Okay. So for this part, symmetric group of permutations, don't think it is over. It has many other dimensions too. But whatever the discussion, whatever the description I have given to you, please remember it word by word. Not like many, much stuff is not there. You have some simple points like what is Sn, how it is looking like. Let's say if someone says what is S3, please make me understand about composition of functions, how inverse you can find, what is alternating group, what is even and odd permutation. Getting my point? What do you get after composition of even and odd permutations? Okay, one more question. Does set of odd permutation also forms a group? Not. You can check it out. Fine. So we move to the other category now. Category किसके लिए? Groups. And that is modulo system. Vivek sir also always told me that whenever you are inside the class, Upendra, ask the student, तुमको आता है लेकिन फिर भी मेरा मन कर रहा है बताने का. So I asked, sir, what will happen after this? Well, many students are there who know कि they don't know, but they don't accept it. So for them, we are a teacher, our responsibility to teach everything on the board. So we will be starting ZM. पानी पी ले. चल. In the modulo system, a definition. A equals B modulo n, it simply implies B minus A is divisible by n, where A and B are integers, either negative or positive, and n is a positive integer. Please remember this definition, the life will be easy here. A B modulo n कहने का मतलब B minus A और A minus B is divisible by n. Fine. So let's say 2 equals 3 और congruent बोलते हैं इसको modulo 5. Is it correct? Please tell me. So if you want to check it whether it is correct or not, what you need to do is 3 minus 2 must be divisible by 5. If this holds, then only this holds, otherwise no. If I say 12 is congruent to 3 modulo 5 question mark, so in that case 3 minus 12 must be divisible by 5. Is it? It is minus 9? No. So this answer is no. You're getting? If I say here 13, so 3 minus 13 is minus 10, then yes, it is divisible by 5. So then this will be yes. Getting? Is that clear to you all? Everyone? Fine. Now let's move for other part. Let's take an example actually. If I say Z5, some people will represent it like 0, 1, 2, 3, 4. Some people will represent it as class 0, class 1, class 2, class 3, class 4. Okay? Depends on what notation you take. Even if you are taking this notation, this doesn't mean this is, please, this is not 1 belongs to Z. This is a class actually. This is a class. Please note it down. This is not the number and that class. That is why this representation will work here more good. When I say this class 1, it says all those elements 1, 6, 11, 16, 21 and so on. Ultimately it says, since 1 can be written as 1 congruent modulo 5, 6 can be written as 1 modulo 5, 11 can be written as 1 modulo 5 and so on. Because 1 minus 1 0 divisible by 5, 6 minus 1 5 divisible by 5, 11 minus 1 10 divisible by 5 and so on. People, how do they actually, when I say this modulo class 1, they say after dividing any number, if 1 is remained, then that element, that number will come inside this class. So for example, if I say what is the class 2 with modulo 5, so you will say this class itself will be containing 2, 12, 17, and so on. I think now the picture will be clear to you guys that if I say Z5 like this, then this is not simply a number. This represents a class where that class itself will be containing infinite number of elements. Is that clear? Everyone? Fine. So now I want to check whether Z5 with this composition forms a group or not. So for that, I will just make a composition table 1, 2, 3, 4, 1, 2, 3, 4. First, let's say addition modulo 5, and in the other way, I will take multiplication modulo 5. Why I am writing here 1, 2, 3, 4? This, if I write Z5 with respect to multiplication modulo 5, then I will represent this set as 1, 2, 3, 4 non-zero classes. Here I will take 0 as well as, where is, oh, set. Sorry. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. With respect to multiplication, obviously, जब 1 by 0 करेंगे, it will not be defined or infinite there. So, in case of multiplication, we consider set with non-zero elements, and in case of addition, I considered with 0 also. So let's compose this table. 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3, 0 plus 4. 1 plus 0, 1 plus 1, 2, 3, 4, 1 plus 4, 5, and 5 is what? 0. किसमें? Modulo 5 में, because 5 minus 0 will be divisible by 5. That clear? So 2 plus 0, 3, 4, 5, 6. 6 again in modulo 5, 1. 3, 4, 0, 1, 2. 4, 0, 1, 2, 3. So again, this whole composition table comprises of the elements of Z5 only. So this is closure. Elements are nothing but coming from the integers, and integers follow associativity. Integers follow associativity. Is that clear? 0 is such an element here which, being composed with any other element or with itself, it will give that element itself. So we call it as 0 as the identity element of Z5 with respect to addition modulo 5. In the same fashion, if you want to know what is inverse of 2, so if I do 2 plus 3, I get the identity element. So I will say 3 is additive inverse of 2, or 2 is additive inverse of 3. In the same fashion, you can know every element has its inverse in the Z5 only. So this forms a group. Not only a group, with respect to integers, we know AB is same as VA, so it is moreover an abelian group. Is that clear to you guys? Now, with respect to multiplication, 1 into 1, 1 into 2, 1 into 3, 1 into 4. 2, 2 to the 4, 2, 3 the 6. 6 in modulo 5. 1. 2, 4 the 8. 8 in modulo 5. 3. 3, 3 to the 6. 3, 3 the 9. Wait. 2, 1 the 2, 2, 2 the 4. 3, 3 to the 6. 3, 3 the 9. 3, 4 the 12. 4, 1 the 4. 8 in modulo 5 is 3. 4, 3 is 12. 12 in modulo 5 is 2. 4, 4 is 12. And 1. Again, I will say these are not simple numbers, those are classes actually. Getting? So here you can also observe closure, associativity, identity, inverse. What is identity here? 1. Let's say what is inverse of 3 here? So 3 composed with 3. No, what it is? Sorry, 3 is composed with 2, then I am getting 1. So 2 is multiplicative inverse of 3 and 3 is multiplicative inverse of 2. So getting my point? Again I will say for the offline classes I may take, मैं 10 मिनट खड़ा हूँ, आप सोचिए. This is online class. So if you have any doubt here, because as my teaching experience says, whatever the points, whatever the dimensions may be, I have discussed here. Now if anything lacks, you just go back on the video or go back on that line, just revise that. Okay, let's move now. One example for you, Z6. So you will check 0, 1, 2, 3, 4, 5. That means modulo 6. So your homework is addition modulo 6 में क्या ये abelian group है, and multiplication modulo 6 में if I take elements as non-zero only, then whether it is a group or not. Here you will be getting yes in the same fashion as I discussed earlier. Here just an example for you guys. If I compose 2 and 3, compose means multiplication you are taking. So 2 into 3, that will be 6. And 6 in modulo 6 is what? 0. But 0 is not in this set itself. So that means with respect to multiplication, this does not form a group. In general, just an exam point for you guys. Zm with respect to addition modulo m is always an abelian group. But if this is a composite number, let's say 6, so 6 can be written as 2 into 3. Let's say 12, 12 can be written as 3 into 4. So then with respect to multiplication, modulo this m into n will be a number, no? Let's say p, not a group. Here star I will mark, just key non-zero elements you are taking here. Is that clear to you guys? Fine. So now with this Zn and Zm, I will just construct a group that will be very much helpful in finding when we talk about order of element, possible the normal groups, cosets and all. There we will use this example, that is quaternion group. We represent it as Q8, somewhere Q4. So Q8 is what here? This is a set. Don't think I have remembered all those stuff because I have been teaching into 12 to 13 years. If you do practice, it will be with you also. Q8, it will be comprises of 8 elements. What are those elements? Plus minus 1, plus minus I, plus minus j, plus minus k, such that ij is equal to minus ji. Okay, and that is k. Jk is minus kj, and that is I. ik is minus ki, and that is j. Also, I square, j square, I square, j square, k square as minus 1. This is Q8. This is abhi how you will do, just composition table 1 minus 1, I minus I, j minus j, k minus k. Here so let's say you want to, just I will give you example 1 or 2. Let's say you want to calculate what is minus I into j. So this will be minus ij. What is minus ij? Check it out. Minus k. In the same fashion, let's say you want to know what is k composition k. So k composition k is k square, that is minus 1. You have already defined in the group itself. So this is set ka pehchan. Q8 is looking like, please remember this Q8 ka structure. Also, this is homework for you guys. Fill or do the complete this composition table like this, because this will make more clear, more this identification will be retaining in your mind. Getting? So this is Q8 ka structure, and this is called quaternion group. This is non-abelian. How I call it non-abelian? Because by the definition itself, it is looking like that Ij is not equal to Ji, because it is equal to minus the Ji. So Q8 is a non-abelian group with 8 elements. So why I am focusing on this Q8? Because in the next proceeding definitions, when I say give me a group of order 8 which is non-abelian, so Q8 must click, must blink in your mind, must blink in front of your eyes. So that is why I am more focusing on the categories here. You getting my point? Fine. Should I remove this point? There is also a K-lines 4 group. K4, E, A, B, C, where AB is BC, sorry, AB equals BA, and that is C. Also A square, B square is identity. Also the C square is identity. A is self-inverse, because A composition A gives you identity. This means A is inverse of A. B is self-inverse. C is self-inverse. E always identity element, self-inverse. Also AB equals BA. Form a composition table with this definition only. Let's say what's happening here. So K-lines 4 group. Whenever I will say give me a group which has all elements as self-inverse, what example will click in your mind? K4, K-lines 4 group. Compositions already I have done a lot for you guys. Getting? Sure. One more, that is the last category of groups. Let's say G1 composition is a group. And G2 with respect to another composition is also a group. Then what we can think about Z1 cross G2. with respect to some composition. You can say Cartesian product. So here you need to remember how this composition is defined. What, dear? How this composition is defined. Let's say I have some element belonging to Z1, I have some element belonging to Z2. So A cross B के अंदर I will be representing like this two tuple. This will be some element of Z1 cross Z2. Getting? Let's say I have some other element Z3. So dear, here G1, small g1 will be from capital G1, small g2 will be from capital G2. Here G3 will be from capital G1, G4 will be from capital G2. If I want to compose these two elements with this composition, I will be having Z1, Z2 composition Z3, Z4. Please make it a point here. Elements of capital G1 will be composed separately. So G1 का composition is what? Star. Whereas elements of capital G2 will be composed by their respective composition. This is the crucial point here for you guys. When I talk about a system or an algebraic structure like this, how the composition is defined. So let's say if I take capital G1 का identity element, capital G2 का identity element, and I have something here Z1, Z2, what it will be, dear? E composition G1, E1 and E2 composition G2. This will be again the same elements G1, Z2. So what it shows? Identity element of Z1 cross G2 will be with entries as identity element of the first group, identity element of the second group, and so on. Is that clear to you all? Fine. So you can cross check about Z1 cross G2. Let's say you want to know, I have some element Z1 cross G1, Z2 belongs to G1 cross G2, and I want to know what is inverse of this element. That means I want to get some element like G1 dash, G2 dash, which gives me the identity element like this. So what it will imply here? Z1 first composition G1 dash, G2 second wala composition G2 dash, and it must be E1, E2. So this must be equal to this thing. That means G1 dash is inverse of G1, small g1 in the structure or in the group this. G2 is inverse, G2 dash is inverse of G2 in the structure second wala. So ultimately, if I want to know what is the inverse of this element Z1, Z2 in this structure, what I need to do is, that will be an element in the group in this set like G1 dash, G2 dash, where G1 dash is inverse of G1 and G2 dash is inverse of G2 in their respective groups. I hope it is clear to you guys how you talk about inverse, how you talk about identity. Obviously, if some people will say, sir, what, you didn't talk about associativity? Yes, I didn't talk about associativity because if this is a group, so element of, okay, yes, if you are writing on the paper, you must write like this. Please listen the statement. Since G1 comma star is a group, so elements of capital G1 follows associativity. G2 comma star dot is a group, so elements of G2 follows associativity. Ultimately G1 क्रॉस G2 के अंदर एलिमेंट्स कौन से आ रहे हैं? एलिमेंट्स तो इन्हीं सेट्स के अंदर से आ रहे हैं. Elements are coming from capital G1 and G2 itself, and those elements follow associativity in their respective compositions. So I will say G1 cross G2 also follows associativity with respect to that composition. Am I clear to you guys? Okay, one more thing I will say. I am here to make you understand things well. If you are planning, if you are preparing your notes, you can write because everything is on the screen. Still, I will suggest whatever I have been teaching inside the classes, you must follow one book. As I told you, Galleon you can follow. With that book, you will continue studying all these stuff because teacher is just to make you, just to help you in understanding the things so that you can save your time. Okay? So, I guess I have discussed many examples or all the possible categories of groups with you guys. Now it's your turn to revise and re-revise. पानी पी ले. अच्छा. So for G2, G1 cross G2 type of things, examples you can consider, no problem. You can talk about R cross R, or you can talk about R cross R cross R. Okay. Q cross Q you can talk. You can talk about Z5 cross Z2. You can talk about S3 cross Z2. Getting? When we will be dealing isomorphism, homomorphisms, in that case we will be studying or we will be dealing all these examples in detail also. So I suggest you guys just try to write all those structures. Let's say if I say what is Z2 cross Z3? So this is just a Cartesian product. What is Z2 dear? 0, 1. Again I will say these are not elements, these are classes. What is Z3? 0, 1, 2. So what will be Z2 cross Z3? 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. So this is my Z2 cross Z3. Now I want to use, or now I want to practice compositions. When I say Z2, it means addition modulo 2. When I say Z3, it means addition modulo 3. Now I want to know ki what is 1, 1 composition, because I am defining, let's say, composition like this here. So what is 1, 1 composition 0, 2? Let's say I want to know it. So how I told you, 1 will be composed according to first group ka composition. Second entry will be composed according to the second composition. तो इसका second composition का क्या है? Addition modulo 3. This is addition modulo 2. So this is 1 plus 0 in modulo 2. 1 only. 1 plus 2, 3. किसमें? In modulo 3. So it will be ultimately coming out 1. 3 mod 3 is what? 0 only. So if I say what is composition of X composition by here, this is the element 1 comma 0 and 1 comma 0 again in Z2 cross Z. That clear? Somebody says, sir, what is 1 comma 1 composition 1 comma 1? No problem. फर्स्ट वाला एंट्री फर्स्ट वाले कंपोजिशन के साथ, सेकंड वाला एंट्री सेकंड वाले कंपोजिशन के साथ. सो 1 + 1 2 in mod 2 0, 2 in mod 3 2 only. So again 0,2 is again an element of Z2 cross Z3. मजा आया? So such a structure you can also talk about. So one homework I'm giving you guys, form a composition table of Z2 cross Z3. I have already told you how you will compose. So just let me just I will give you a hint, rest you will do. So let's say this is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Similarly here 0, 0, 0, 1, 0, 2, 1, 0, 1, 1 and 1, 2. So let's say this is again 0, 0, 0, 0, composition 0, 1. So पहला वाला एंट्री 0 + 0 in mod 2, अगला वाला एंट्री 0 + 1 in mod 3. So 1 in mod 3 again 1, 0, 2 same line आ जाएगा. Let's say you want to compose this thing 0, 2 composition 0, 2. So 0 + 0 in mod 2 0, 2 + 2 in mod 3 4, 4 in mod 3 is 1. So this element will be looking like 0, 1. So this is homework for you guys. Fill this composition table. Getting? So things which you can confuse, which you take time in reading books, for that I am here, and I'm not just here to waste your time, because many of you guys are going to write this 2022 mains. So for them I'm very much confirmed that I have to cover things well and detailed manner so that you people can save your time. Is that clear? In the same fashion, if I discuss about, let's say, S3 cross Z2. So dear, what is S3? I sigma 1, sigma 2, sigma 3, tau 1, tau 2. And what is Z2? 0, 1. Or you represent as class 0, class 1. So I want to discuss I, 0, I, 1, okay? Sigma 1, 0, sigma 1, 1 means S3 cross Z2. I will write here elements. I want to calculate, let's say, sigma 1, 1 composition sigma 2, 0. So how I told you, sigma 1 composition sigma 2 in the set S3, in the structure S3, 1 composition. I think picture is clear to you. बस अब क्या है, सिग्मा 1 कंपोजिशन सिग्मा 2 क्या निकला था, सिग्मा 3 and 1 here. ठीक है? So you got element of this set only, S3 cross Z2. So you can do this exercise. Compositions I told you, how you will compose those things. You can write S3 cross Z3, S3 cross Z4. If you are fresher, you are not going to write this 22 mains. I will suggest you guys to complete all these composition tables. Okay? Hint I have given you. And one more thing, one more announcement I want to make here. You people will be provided PDFs, class notes, the PDF. You people will be provided questions also, assignments. Also, at the WhatsApp group, you can send me your queries. Let's say you compose this table and you want to make confirm. One thing is that you have book, you can cross check from there, or you can just do me a WhatsApp. I will cross check that also. Fine. But my suggestion for you guys, do this exercise. If you think, okay, ये तो मुझे आ गया, this is the dangerous point for you guys. आगे बाद ना कहानी बहुत खराब हो जाती है. फिर हमें ऐसा लगता है, okay, this is easy. But I will say, मुझे देखो ना, I have written so many times that things are na just in front of eyes. So do this rigorous process. Sigma 3 composition tau 1, sigma 2 composition tau 2. What is coming out? Let's say कि I have the element sigma 1 2 3 1 3 2 1. I want to compose. That means I want to know image of what is 1 का image. 1 का image 1, 1 का 3, 2 का 3, 3 का 1, 3 का 2, 2 का 2. That's it. हो गया. This is the exercise you do. Okay. Z1 cross G2. Why I have said this to exercise? Because if you are doing this exercise for 4 to 5 times, S3 Z2 फिर ये तो खिलौना, you will be looking like twice only. Getting? Fine. So these are the categories of examples. These are the things. These are some standard groups which you need to carry with you. Is that clear? So after this, we will be dealing some other definitions. How those definitions will be more clear for you guys. For that, I will be using these groups. What? These standard groups. Fine. So for the next lecture, you people are suggested to remember all such structures. बहुत ज्यादा है नहीं. क्या है आपके पास? इनफाइनाइट में C, R, Q, Z. फाइनाइट्स में ZM, K4, K lines for group, SN, group of permutations. Group of permutations needs bit details. I have done this in this class only. Q8 quaternion group, non-abelian group of minimum order 6 से मिलेगा. S3 मतलब number of elements in a group is called order of that group. Is that clear? So all these structures, roots of unity, yesterday I discussed with you guys. So please remember all these structures. Cartesian product wala, especially you remember. In the next lecture we will be discussing about order of element, and we will move on cyclic groups as well. So for all those stuff we need these examples. If these examples will be running in your mind, everything will be very clear, very crystal clear. So abstract algebra will become easy once you grasp these exercises, these structures. Okay guys, so let's have a short break of 10 minutes, like 10 मिनट के बाद अपन वापस से मिलेंगे, and we will continue this lecture. The lecture stream will be like this, our 1 hour and 15 minutes like that, and then 10 minutes gap, then another lecture. Okay, fine, let's wait for